Alright, so here we are at the top 5 diagnostics command for your Fortigate, and we start with the first command, which may look a bit simple, which is the get system status. Now this command is very basic, but it gives you a lot of information. It gives you the virus and IPS database version. It gives you the serial number of your Fortigate. You can tell if you have a hard disk or are you using only a flash memory. It also tells you, are you participating in an HA cluster or not. It gives you information of the operation mode. Are you working in a NAT mode or maybe a transparent mode? Are you using another virtual domain or are you using only one virtual domain? So a lot of information in that simple command. This second command is the get hardware NIC and the interface name. In our case, let's look at our WAN interface. Sorry, it's WAN1. And that tells you of each interface its MAC address. Does it support any hardware acceleration? In our case, we support MP4 Lite. Do you have any dropped packets in your interface? Is the status up or down? Are you working in a full duplex or maybe half duplex? And what is the speed of your interface? In our case, it's 1 gig. Our third command is the get system performance status. Now, personally, I love that command since it tells you a lot of your Fortigate. Now, at the top output, you will see how many CPUs your Fortigate module supports. The following thing is the RAM usage. And at the bottom, the output shows your network traffic, the amount of average sessions per minute, and so on. So you have your CPU usage, you have your RAM usage, and your network usage. Next up is probably one of the most known when you deal with the Fortinet firewall, and that is the Diagnose debug flow, which actually shows you the flow of your traffic from the CPU perspective. So you have to enable it. Let's enable. And then you use the Diagnose debug flow. You usually use filters, since if you're not filtering your traffic, there could be tons of traffic that will be shown on your command line and it won't be so easy to analyze. So let's filter a specific address, which is the 10.0.3.16. And now the next thing to do is to diagnose debug flow and trace. And let's use a count of 10 packets to show. And it shows us tons of information from the specific source host that we have chosen to just about anywhere that the traffic flows. It shows us the source NAT and the destination NAT, and it shows us the policy that is being used. A great tool for debugging and troubleshooting. Alright, now the next command is the diagsys session list, which shows you the sessions that are being handled on your Fortigate. And that also shows us tons of information. You can see the different protocols that are being used. You can also use it using specific filters or grabbing different source address, and that will show you a limited portion of the information that is relevant towards a specific host only. And Our last command is the diag which is similar to the top command in Linux, and that shows you each and every process in your Fortigate. It shows you the process name, the process ID. It shows you its state. Is it asleep or maybe it is running? It shows you how much memory is being consumed and how much CPU is being consumed. Whenever you have issues with one of the processes in your Fortigate, that is probably one of the first places to check. And before we end this video, please don't forget to subscribe. Your Wi-Fi throughput can vary for different reasons. Noise, misconfiguration of the access point, co-channel interference, adjacent channels, and so on. But one of the main reasons is obstacles in your physical space. Obstacles that will make your RF signal reflect and propagate to different directions. One of the mechanisms that are used in Wi-Fi is the guard interval. It protects symbols in your packets from getting back and damage other symbols. Mostly we use a guard interval of 800 nanoseconds, but since 802.11n we can also use short guard interval of 400 nanosecond. It can help you increase the throughput in your Wi-Fi deployment, but don't use short guard interval whenever you have high density deployment. Let's try it out, and please comment me back on this video and tell me if it helped you to increase your throughput. I can tell you that in my case, it actually helped me to increase my throughput in about 10%. So let's do it. So let's move over to the CLI. Let's configure the wireless controller WTP profile. And now let's edit one of the most used access points, which is the 4221. Let's configure its radio. Alright, let's see the full configuration. And as we can see, the short guard interval is disabled. So we can set the short guard interval to be enabled. That's about it. Now, don't use it in any deployment. Learn what happens in your network in real time and make decisions by it. Hey everyone. So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now if I'll type the get command, I will see that currently I don't have any virtual switch already configured. Let's name one. Let's call it. All right, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. All right, let's get back to our. All right. So now let's use the same command as before. Config system switch. Sorry, config system virtual switch. And let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. All right, now let's refresh our interface pane to see our new virtual switch. And there it is. Now, if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN2 as our alias, and let's get him an IP address, and that's right. I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. One of the coolest features of your Fortigate is its ability to packet capture just about any traffic that flows from different sources towards different destinations. Now you can capture packets using two ways. The first one is using the GUI itself in network packet capture, and you can enable different filters, but the way that I like is the TCP dump way. That is doing it in the command line interface. And I didn't mention TCP dump for nothing. The syntax is very similar. Now, if you use the GUI option, you can import the results into a pickup file and then open it in Wireshark. But we will use the CLI way, as I find it much more quicker to analyze. So the basic syntax for capturing packets is the diagnose command, and then we'll use this sniffer and packet. And now we will choose which interface to make the sniffing. Now we will not choose specific interface, so we'll use the any interface. We will not use any filter right now, we will use it very soon. The amount of verbosity, the amount of details which we will use is 4. Packet count will be 10. And we'll also use a timestamp using the A command. Now let's open it so we can see it much clearer. And we can see that we have action in our when1 interface with a source of 10.0.3.139 towards the Fortigate appliance itself, which is in the 10.0.3.16. We have different TCP packets using different flags, and we will use a specific filter that will define the if we can see any action that is being done using the ICMP protocol. If we will use the same command without the A at the end, we will get the same results, but without the timestamp. So use it when troubleshooting packets. Now, if we'll want to use, let's add the A. If we'll want to use a specific filter, as in the ICMP protocol, so we will see that once we enter the name of the protocol, and take a good notice, we have only 10 packets that are being shown. We can also use 20 packets and we will have 20 packets. We can use many filters in our command. Now you can look at the Fortinet documentary to see which filters are available when doing packet capture, but the most used are source and destination. We can determine specific host and specific protocols. So if we'll use the diagnose sniffer packet any, we can use host 10.0.3.139, which is my Mac, and ICMP as the protocol that I'm looking for. And we will use the verbosity, the level 4 verbosity, which is the default verbosity. One of the major keys to understand how your Fortigate works is to understand how it handles session, how it handles the dialogue between clients and servers. Now, Fortigate is a session-aware firewall. We all know the get system session list, which gives us an overview of the sessions that are currently running on your Fortigate between different clients towards different destination. We can also see the source NAT. We can see which protocol is being used. Another well-known command is the Diagnose session list, which we can also filter based on the host IP or destination IP. But I would like to show you another command, which I'm not sure that is that popular, which is the get system session info full stat. Now let's make the screen a bit bigger. Now what we can see in that command is the session table size, that is the current session table size, the number of entries that is possible in the session table. Another thing we can see is how many sessions are being used right now. In our case, we have 64 sessions that are being used right now. The session count is the number of sessions in the kernel. Now we can also see several more things. We can see the memory tension drop. That is the number of dropped sessions due to a system that is running out of memory. Another very interesting information that we can find is the ephemeral, which is actually a buffer that protects our table, our session table, from getting overloaded. That is, if a denial of service attack is happening. Now, the first number is the amount of sessions that are in use. The second number is the maximum number that is allowed. Now, if we see that both numbers are very close, then there is a good indication that a denial of service is actually happening on your organization. The other thing that we can see is the TCP sessions. Now, looking at the TCP sessions, we can see their state. Each session has a different state. So we can see that we have 11 sessions in established state. That is, they have finished the three-way handshake connection. The connection now is established and they can transfer data. We can also see that we have one session that is in a time wait state. Now, the time wait state is a special state that happens when a connection termination request is sent, and our Fortigate actually reserves some time to ensure that the remote side received the termination request. This video is all about setup tips for your Fortigate, and we are starting right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click the bell notification and you won't miss anything. One of the most common questions that I get every time is, how do I set up my Fortigate? I'm not interested currently in any intrusion prevention system sensors. I'm not interested in IPsec VPNs. I just have several interfaces connected to different clans, and I need to set up my Fortigate for truly a basic operation. So in this video we will look at the basic setup configuration. As you know, in my channel you have tons of videos that deals with different aspects of your Fortigate. So the very first thing is to set up your administrator profile. You're probably the super admin of your Fortigate, so make sure that you connect through trusted host. If you need to set up a new admin, maybe a professional admin that will be responsible for another virtual domain or different aspects of your Fortigate, do it. So the next thing to do is to move over to network interfaces. You probably have different LANs connected to different interfaces in your Fortigate. In each interface, don't forget to write down an alias. It will help identifying which LAN belongs to which interface. Use specific roles for specific interfaces. Use administrative protocols carefully. Don't just let anyone ping from that interface if it is not needed. Use DHCP server and use DHCP server scopes so you can create different DHCP options for that local area network. You can block specific MAC addresses from receiving IP addresses. And use device detection and active scanning. You want to know which devices initiate traffic on that interface. Now the next thing to do is to create or configure a static route that will lead to your ISP. Now it is usually created using the default route, which actually means that any packet that is destined to anywhere and it does not have any entry in the routing table should head up towards the specific gateway, which is usually the WAN gateway. The next thing to do is policy and objects. That is the bread and butter of your Fortigate firewall. It is where you create rules that match any traffic that comes in or gets out of your Fortigate. Assuming that it matches the traffic, you have two decisions. The first one is to accept, the second one is to deny. Now you can create different policies according to different topologies. The basic policy is the full access policy, which allows local area network to get out to the internet through the WAN interface. So incoming interface can be just about any LAN in your network. The outgoing is the WAN interface. Source can be different users' devices, but let's assume that we deal with just about anyone. Destination also can be specific destination, but let's assume that any destination is allowed. You can set up different scheduling and services. Now, Again, you can deny specific protocols, but for our case, we will allow any service. Now, the learn policy is another topic that I have made a video specifically on that, but that's not the issue right now. Now, whenever Fortigate matches the traffic, the next decisions are we going to log the traffic? Are we going to net the traffic? Net is also very, I would say, not difficult, but it is a tough topic to understand. And then it implies the security profiles, which can be antivirus, web filtering, IPS, and so on. And our last setup is actually moving into the Logon Report and see whatever happens in your Fortigate. Now, there's a lot of happening whenever traffic comes in and gets out, whenever an admin logs in into one of the interfaces, whenever there's a VPN tunnel that initiates or stops working. You need to maximize your understanding on what is happening on your network. And the best thing to do is to look at the Logon report and understand your network baseline. For years, it is known mostly as the #1 web application vulnerability, SQL injection, when a user input becomes an attack vector. Don't go anywhere. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. To understand SQL injection attack, we have to go back to the basic. So we have a web app, it runs on our browser, and just about any web app has different input fields that we enter user credentials or we enter reviews or just about anything, comments and so on. Whenever we do it, our web server that hosts the web app contacts its database. It does so using a very specific language which is called SQL. SQL is actually a structured query language, a special language that allows us as users and allows our web server to update, to delete, or to request information from the database. To do so, our web app sends SQL statements to the server. Now you can send a batch of SQL statements. There is a group of 2 or more SQL statements that are separated by semicolon. The server processes our request and returns back the results. Up until now, fantastic. It works just fine. Now, where is the vulnerability? When our web app just doesn't sanitize. It doesn't sanitize our user input. It doesn't differentiate between plain text that is used as the user input and an SQL statement that is entered in the input field and sent to the database. Let's look more closely. When we have a user input, the code, the application code looks something similar to that. When we enter our name, that is our username, it is being added to the code itself. Now imagine what will happen if I enter the following code instead of my name. It is actually an SQL statement that was entered in our input field. So now our application code looks like that. Offer, which is my username, or 1 equals 1. Now the database pulls down the records for every user wherever 1 equals 1. Remember, 1 equals 1 is always true. The SQL is actually a valid SQL statement, and it will return all rows from the user's table since or 1 equals 1 is always true. So our pure plain SQL statement is being treated as any other text input. It is being injected directly into our database, and from there the opportunity for a malicious attacker is huge. Welcome to our Fortigate top 5 tips, and this time we are dealing with the ping command. Tip number 1. When we use the ping command, we use the execute command. So we'll use the execute ping and we'll choose our destination as 8888, which is Google's DNS server. Now we can see that our ping size is 56 bytes and Fortigate sends 5 packets at a time. Now we can change the size of our ping. How do we do it? We use the execute ping options. Let's view the settings. All right. And now if we will use the execute ping options, data size, we can choose ICMP packets to be in different size. Let's choose 90. So now our ping size is 90 bytes. Let's choose the same target. Execute ping towards 8888. And you can see that our ping size is 90 bytes. And to our second tip. Now, if you do networking for a long time, you probably send continuous ping packets towards different destination, different interface. So you have to change the amount of packets to be continuous or to be at a different size than the 5 packets that are sent by default. How do we do it? We use the execute ping options and we use a different repeat count. Currently the repeat count is 5. Now let's change it to 15. And now let's ping again and let's ping the Google DNS server and let's see how many packets are being sent. And we can see that we have 15 packets that are sent. And now for our third tip, let's clear that out. Now we have different interfaces in our Fortigate and sometimes we wish to send ping packets from different interfaces. So how do we do it? I have currently an interface at the 10.0.4.1. So let's use the same execute ping options. And now let's choose a different source. In my case, it's the 10.0.4.1. And now if I'll use the same ping command, the packets will be sent from the 10.0.4.1. Moving on to tip number 4. Usually a ping command is being discarded after 64 hops. Now we can choose a different integer. We can choose an integer between 1 and 255 hops. How do we do it? We use the same, sorry for that, we use the same execute ping options, time to live, and let's choose 220 hops, 220 hops, and now our ping packet will be discarded only after 220 hops. Alright, and now let's move over to our fifth tip. Sometimes as an administrator, you use different settings. Let's change the settings of our ping command. Let's use a repeat count of 8. Let's use a different data size. Let's make our ping size 80 bytes. And let's use a different source. Alright, let's use the 10.0.4.1 as our source. Now, if we will use the view settings, we will see that our repeat count is 8, our data size is 80, and our source address is the 10.0.4.1. Now, you want to reset those settings. What do? You use the reset command. And now if we'll take a look at the view settings, we will see that it all came back to the default settings, which are 5 packets, 56 bytes, and the source is according to the interface that you work within. Now, if you like our channel, please subscribe. In this video, I'm going to show you the 5 top routing commands for your Fortigate, and we are starting right now. Welcome to our top 5 commands, and this time it's all about routing. Your Fortigate is not only a next generation firewall, it is also an OSI layer 3 device, just like any other professional router. So let's start right now. And the first command, our first command will be the get router info routing table. And now there are 2 variants of that command. You can see the full routing table, including the inactive routes. That's the full routing table, including inactive routes. And you can see only the active routes. And there we use the all with our command. Our next command, which is very useful whenever we wish to see more details on a specific destination, we can use the get router info routing table. Now we'll use the details for our destination, and this one it's going to be the default route. And we can see that when we ask for the default routes, we get 2 static routes. We get one from the WAN to interface, and its IP address is the 10.0.5.2, and the second one, which is actually the active one, is the one from our WAN 1 interface at the 10.0.3.1. We can also see the different administrative distance. The active one has an administrative distance of 10. The inactive one has an administrative distance of 20. There are times when you have 2 static routes to the same destination. Both static routes have the same priority, have the same administrative distance, and you wish to load balance the traffic between them. Fortigate load balances the traffic automatically, but the load balance algorithm can change. So let's change our 2 static routes to be within the same priority and administrative distance. Let's look at both. They are in the routing table, in the active routing table, and yes, they are. And now let's configure system setting. Sorry for that. It always happens. And set v4 ECMP mode. ECMP is equal cost multipath. That says actually that whenever we have 2 static routes using the same priority and administrative distance, Fortigate will load balance the traffic. How will it load the traffic? Well, there are actually 4 different algorithms using the same source IP, using an interface weight, usage, that is whenever on one interface you get into a specific threshold, the traffic moves to another interface, and you can also use the same destination and source IP. And now we move on to our fourth command, which is the link health monitor. Link health monitor is a mechanism that protects your Fortigate from a route failover. Now assume that your Fortigate has two ISP connections, ISP1 and ISP2. The first connection, which is WAN1 connection, is active since it has a lower distance. The second static route is not active. Now whenever Fortigate notices that the route through WAN1 is not working anymore, it transfers, or it makes the second route, the second static route, it makes it active. It makes it active so it can route the traffic to the internet. How do we do it? We use link health monitor. Config system link monitor. Edit, that is the name of the link health monitor. Set the source interface. And now set the server, that is the server that we will probe. It can be 8888, which is Google's DNS server, or any other stable server. Set the gateway IP. Now set the protocol. It can be using ping, or it can use TCP echo or UDP echo. And then set the update static route to enable. Moving on to our last command, which is the Diagnose firewall proute list. Now, this command actually shows us the policy-based routes table. Now, you can create a policy-based route, which is a much granular way to create routes using the policy routes under the network menu. Use it carefully, and use it only when you have a very specific needs from your route entry. Hey everyone. So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now if I'll type the get command, I will see that currently I don't have any virtual switch already configured. So let's name one. Let's call our virtual switch, let's call it marketing. And let's set it up from the physical switchboard. All right, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. All right, let's get back to our. All right, so now let's use the same command as before. Config system switch. Config system virtual switch. And let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. All right, now let's refresh our interface pane to see our new virtual switch. And there it is. Now, if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN2 as our alias, and let's get him an IP address, and that's right. I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. Let me show you the best user setting tips for your Fortigate, and we start right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have your users connected to one of the interfaces in your Fortigate and you want to set up different settings as authentication timeout and so on. So head over to the command line, config user settings, and the first command is set auto timeout. Let's move over between the different options, and there you can choose different integers from 1 minute up to 24 hours. Now the default is 5 minutes. Personally, I prefer to set the timeout to 30 minutes. So choose whatever suits you as an administrator and your company's policy. The second command is quite important. Set auto timeout type. Now there are different types of authentication timeout. There's the idle timeout, the hard timeout, and the new session timeout. What is the difference? In an idle timeout, Fortigate has to see traffic that is coming from the user. If it doesn't see traffic coming from the user's IP address for the time we configured as the authentication timeout, well, it deletes the authentication entry and asks the user to authenticate again. Now, in a hard timeout, it doesn't matter if there is a traffic or not. After the authentication timeout passed, the user will be asked to authenticate again. That's a hard timeout. The last option, use session timeout. Well, that's the case where you have a timeout. Let's say it's 5 minutes. You head over to a site, you start to download a file. Now, after 5 minutes, the file download is not terminated. It still goes up and downloads to your computer. But if you head over to another site, that is, you create a new session, you will be asked to authenticate. Another option that every administrator needs to configure is the amount of failed attempts before the user is being blocked. That is the number of time a user can fail authentication until it is being blocked. Now, the default is currently 5. You can change it up to 100 times. I usually use 3 times. So that is set auth invalid maximum, that is the maximum number of invalid login attempts, and let's set it to 3. Some of your user will probably head over through a captive portal, that is outsource employees and so on. So you can set the set auto portal timeout. That is the amount of time that those employees will need to authenticate again to an integer of between 1 up to 30 minutes. One of the key elements of any authentication scheme is the usage of passwords. We use passwords all over in our Fortigate. We use it when we configure new users. We use it when we configure our admin profiles. We also use it when we configure SSL or IPsec VPNs. We use passwords all over. We will look at password entropy, how random or how difficult it is to predict your password. Let's start. So an entropy in plain words is the difficulty in guessing a password either in a brute force attack or a dictionary attack. Now, how do you calculate entropy? Well, you do it using the length of your password, the complexity of your password. Are you using uppercase characters, lowercase, or maybe you're using uppercase and lowercase? Are you using symbols? Are you using numbers? The more complex your password is, there is much more entropy. And the last parameter is the randomness of your password. The more random it is, it adds up more entropy. Now, randomness is an issue when it comes to computers, since computers can actually generate a pseudo-random numbers. All right, so let's look at an entropy example and things will be much more clearer. So we are calculating entropy using the following formula. H equals L. L is the length of your password. H is the total binary bits of an entropy. Entropy is calculated using bits. And N is the number of possible symbols in a password. So a password length of 8 characters from the entire alphabet, that is uppercase, lowercase, symbols, and numbers, will get us to an entropy of 2 to the 52. So this password has about 52 bits of entropy, and it is a strong password. The higher your password entropy, the less predictable your password patterns are for a computer. As far as password, 36, 37 bits of entropy are rather good. Another example is when we use a keylog that has only 10 digits, that is 0 to 9. So if we use only 5 characters, you know what? If we use 4 characters, we usually use 4 characters as our passwords in a panlock keypad. So that is 10 to the power of 4. 10 to the power of 4 is 10,000. So the key space of the password is 10,000 passwords. If we use 5 characters, out of the 10 digits, it is 10 to the power of 5, which is only 100,000 passwords, and the entropy is only 16 bits. So this is not a good password in the digital world. It may be a good one in the physical world. If we use only lower letters in the English alphabet, we have 26 letters in the English alphabet, and we use a password of 7 characters. That is 26 to the power of 7. It gets us to a total of 8.3 billion passwords. The entropy there is 32 bits only, so still it is not a good password. If we use 8 characters out of the 26, that is 26 to the power of 8, we have 208 billion possibilities. That's the key space. The entropy is 37, which is quite good, though nowadays we use passwords with more complexity, that is using the uppercase and the lowercase plus numbers and symbols. We can use the command line to diagnose and learn more of our SD-WAN member interface. Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. We can use our command line while configuring SD-WAN for different tasks. One of them is to use different protocols that will be used towards the server that was chosen in the health check. So if we look at the performance SLA, let's choose one. And we can see that on the graphical user interface, we only have two options to ping our server, that is using ping and HTTP. Now, if we will use the command line, config sys virtual WAN link, config health check. Now let's edit the performance SLA that we have chosen, that is SIP. Let's see what is chosen. Show full configuration, and we can see that the protocol that was chosen is ping. Let's set protocol, and now you can see that we have the ping option, the TCP echo option, the UDP echo option, HTTP, and TWAMP. So that is something that is available on the command line and not on the GUI interface. Another thing that we can do or actually see using our command line, let's use the Diagnose virtual WAN link. Let's choose the SIP. You can't see it that way. Let's choose the SIP health check. Now we can see the status of each member in our SD-WAN, in our virtual SD-WAN interface. In terms of packet loss, we can also see it on the graphical user interface, but that is also one way to look at the different members. We can see that it is alive. We can see that we have no issues currently with packet loss. And we can see the statistics for latency and jitter. Currently, the other members are not alive since I have not enabled them on my Fortigate. Now, whenever we use performance SLA, we are actually telling our Fortigate to probe different services. We can configure up to 2 servers that will be used as beacons. We are doing that to check the status, the health of the different members of the SD-WAN interface. Now, whenever our Fortigate probes that server, it is actually using a route entry that is created. Let's see that route entry. So we will use the get router info kernel, and those entries are actually flagged. They are created in the kernel. They are called fib entries, and they are flagged as proto 17. So to see them, we will use the grep command, and we will use the proto equals 17, and we can see, let's make that a bit bigger. We can see the different routes. They are being sent from the different interface gateway towards the different servers that we have chosen. The first one was actually the Google DNS server, which is 8888, and the second one is 1111. Hey everyone, so here we are at part 4 of certificate operations in your Fortigate. This video series spreads some light on the importance of certificates and why do we use them. It is not a tutorial of how to create a self-signed certificate. We will get to that. It is actually the theory behind digital certificates. So what did we have? We had symmetric encryption, where the two parties share the same secret key. We also learned of asymmetric encryptions, where we use a key pair, a public and a private key, different keys yet related mathematically. And then we had, at part 3, we had hash functions, a one-way function that takes any input and transform it into a digest, a hash value that is not reversible and is collision free. That is, no two different inputs can produce the same hash value. Alright, so let's connect the dots. A CA, which is a certificate authority, issues digital certificate. This digital certificate also contain the public key of the entity who requested the digital certificate. It can be just about any web server out there. Another thing that it does is signing the digital certificate. How it does so? It hashes the digital certificate along with the public key and then encrypts it using its private key, using the CA's private key. Now, when a browser connects to a secure web server, it gets the certificate along with a digital signature. Think about it as two different files. It opens the digital signature using the public key of the CA. It has the public key of the CA in its certificate root directory. Now, any browser keeps its certificates, its CA certificates, in a different place. Now, as the file is being decrypted, he gets the hash of the digital certificate value. He then takes the digital certificate, the original one, hashes it using the same hash algorithm that was used by the CA. The type of the algorithm is also present on the certificate itself. We can see it right here. If both hash values are the same, then we have a proof that the entity who sent the certificate is the one who it claims to be. So we have used asymmetric encryption and hash functions to prove the authenticity of the entity. Now, the two parties, the browser and the web server, will negotiate the symmetric encryption that will be used as the encryption algorithm, the cipher itself, to encrypt the communication between them. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the topmost CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features we saw using the Diagnose command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. Whenever you open an app in your Fortigate, you're actually creating a process. A process is responsible to ask the kernel for resources, CPU resources, RAM resources. How do you manage them? Using the diag sys top command. Let's take a look. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. There are some different ways to sort up the processes that are running on your Fortigate, but one of the most popular diagnose command is the diag sys top command. Now, whenever you launch the diag sys command, you will see the different processes that are currently running on your Fortigate. Now, you can filter those processes using the diag sys top, and now you can set up a number, an integer that will actually behave as the interval between the processes and the amount of processes that you wish to see. I've chosen 5 and 20 processes. So I have 20 processes and the interval that they will refresh is 5 seconds. Now let's take a look at the information that is being shown here. Let me stop just to look at those processes without interfering. So what I have here is the name of the process. New CLI is the JavaScript command line, HTTPS, the DNS proxy, and so on. I also have the process ID, which I may use if I wish to kill that process. I have the state of the process, which can be a process that is running, as this one, or a process that is asleep. Moving on to the 2 more pieces of information that we have. The first one is the amount of CPU that a process is using, and the second one is the amount of memory that the process is using. Now you will also see above the processes some gibberish, such as the 99i. What does it mean? It actually means that currently the CPU is currently 99 idle, so there aren't many processes that consume the CPU resource. You can also see the amount of free memory that our Fortigate has. That is the number that comes with the F character on the right. And lastly, the 1S actually mean the percent of system processes that are using CPU. In other words, that is actually the CPU usage in percent of system processes. That's the overall information that we get using the Diag system. But how do we kill processes, and how do we toggle between processes that consume more CPU or more memory? That is coming up in the next video. So your access points have been deployed. How can you limit the amount of clients that will connect to your access point, to a specific access point? Client limitation is crucial whenever you have high density deployments and you want your clients to move between access point whenever there is a good signal strength between them and an adjacent access point. Well, you can limit the threshold, you can limit the amount of clients. It can be 10, 20, 30 clients per access point. But you can also control the threshold, the load balancing threshold. So whenever a client has enough signal strength to another access point, it will roam to that access point. Let's see how we do it. All right, so let's use our command line to enable the access point handoff, to limit the number of clients to that access point, and to configure a threshold. So let's configure the wireless controller, WTP profile. There it is. And let's use one of the default profiles, which is the 11N only. Let's configure the radio. And let's set the access point handoff to enable. All right. And now let's move back and configure the handoff station threshold and limit it to only 15 clients. So only 15 clients will connect to that access point before the load balancing mechanism will start to work. And the last thing to do is to set the handoff RSSI. And let's use a handoff RSSI of 30. Now, in the case where our clients will try to connect to our access point, the controller, our Fortigate that serves as a controller, will signal the client to connect to another access point. One of the key topics that you will master using your Fortigate firewall is policies. So, what is a policy? Why do we need policies? And how do we configure policies? Well, a policy is a rule that when a traffic flows from one interface to the other, it matches different patterns of the traffic. It matches the interface that the traffic comes from, the destination interface that the traffic is heading towards. It also matches the source of the traffic, its IP address, if it belongs to a user or a user group. If it belongs to a specific device, it can be a PC, it can be a smartphone. And when done, when traffic matches your rules, your specific patterns, then the policy takes the security profiles action, which is an intensive process that looks into the payload itself and looks for different patterns to identify the traffic, to look for viruses, to look for anomalies. We will look at IPS and antivirus later on. And then, when all goes well, the policy decides whether to NAT the traffic and whether to log it. Policy is actually a three-step procedure. Let's look at a very simple policy. We will create one now. Now, on our policy, the first part is the part where we look for matching traffic. Let's name our policy. Let's call it full access. And let's decide that we wish to allow any user that sits on a specific LAN. It can be your marketing division LAN, it can be your finance LAN. Each LAN will probably have a different subnet to get out to the internet over the outgoing interface, which is our WAN interface. Our WAN interface is the interface that is connected to our ISP. Now, in terms of source, we will allow any source to get out to the internet. We can also limit it to specific users or different user group. We can create a user or a user group using the plus sign. We can also limit the traffic to a specific device. So if we, for example, want only Linux devices to get out to the internet, we can limit it to a Linux PC. Now, we will not do it. As for destination, we are not limiting. We will let anyone get out to any destination, but we can limit the destination towards a specific address. As for scheduling, we can limit our policy to work on a specific day, on a specific hour, but we will not do it. Anyone can get out to the internet always. And the last part of the first step in our policy procedure is this service. We can limit this service to be HTTP, HTTPS, or any other service, any other protocol that we wish to limit our users, but we will not do it. Users can use just about any protocol, any service. And then we decide on the action. Are we accepting the traffic? Are we denying it? Or maybe we are using it as a learn policy. A learn policy is a very specific policy that actually triggers security profiles beneath that no one really knows that it's there, and it learns our traffic and creates a report that we can look into and see users' traffic, most used applications, threats, and so on. The second part is the UTM profiles. We can initiate any UTM profile, any security profile on our policy. And the third part is whether we are enabling NAT. We have seen how NAT works using a NAT overload, IP pools, or maybe central NAT. And then we decide whether we want our policy to be logged with log all sessions or only security events. That's the basics of a simple full access policy.